Welcome to this symposium on assessing the human infectious reservoir for malaria. My name's Chris Drakely. I'm from the School of Hygiene and Tropical Medicine in London. And myself and my co-chair, Ivo Muller, are going to present, along with some colleagues, a series of talks looking to essentially measure human infectiousness. And these talks are some preliminary work, are related to three programs that have been linked programs that have been funded by the Bill and Melinda Gates Foundation, largely looking from myself and Tern Bousma at infectiousness of humans to mosquitoes in Africa. Ivo and his colleagues are looking in defining infection dynamics in non-African settings. And then Matt Marty is representing the Harvard group, who are looking at the molecular characterization of those infections. So what we're going to do is have a series of talks, after which we'll have a couple of points for clarification, but at the end we'd like to have a more open discussion with questions from you on a broader remit, I suppose. What I'd like to do is just give a few slides, a brief introduction as to what we're thinking about and what we mean when we're talking about the infectious reservoir of malaria. Essentially, we are asking the question, is who within an endemic population infects mosquitoes? We know that the bulk of our control measures rightly focuses on reduction of morbidity and mortality in the smaller members of our communities, endemic communities, and that they do bear the highest parasite burdens. But they also receive treatment, we hope. They also use preventative measures such as insecticide-treated nets. And they have relatively little immunity, which may mean that infections are brief, high density, but curtailed by drugs. Whereas in the older individuals, that is that man's wife, by the way, she's quite short, and they have some immunity, the infections will be more chronic. They also have different behavioural patterns. So what we're trying to do is actually work out, in the context of the Foundation's idea about elimination, is trying to put a better marker on who infects mosquitoes within that population. The way that we do this, or the way that this has been classically done, is by xenodiagnostic surveys. So this is effectively a random sample of individuals within a population who you take blood from and feed to mosquitoes, either directly by a membrane feeder, or you can take some part of their body and feed mosquitoes on that. So it's a non-selected group of the population, a random group. So you're not selecting, ideally, you're not selecting on any parasite level. And so these are some papers and some historical attempts. Probably the oldest here is done in 1950s in Liberia, probably not a wise thing to do now, where a random section of the population were fed to mosquitoes. And then what these metrics are essentially working out, of those X number of individuals, how many were infectious to mosquitoes, just one mosquito out of any fed. And then this column here is looking at what proportion of each age group comprised that 5.7% in that top one, for example. And so there's three kind of points that I want to make about this slide. The first is that actually there's an awful lot of variation in the methodology about how individuals were identified, how they were, the feeding experiments were performed, what mosquitoes were used in those feeding experiments. There's an awful lot of methodological variation, which makes it quite difficult to directly compare those studies. Having said that, the second observation is that those proportions of infectious individuals all are, to me at least, remarkably consistent, or within a range that supports the observation that they're probably correct. The third observation is that what we see in the vast majority is infectiousness in all age groups. It's not restricted to those young children. There are a few settings in which those infections predominant, or those individuals contribute the predominant number of infections, but there are other settings where older individuals are really contributing significant numbers of infections to mosquitoes. Those studies have further limitations in that there are invariably single time point surveys. And whilst you hope that the kind of rationale behind doing a cross-sectional is that you are capturing individuals representative at that point in time, and repeated cross-sectionals would give you that similar picture. But we know that during an infection, parasite densities change and fluctuate, and the assumption is that infectiousness does as well, and we don't really know how that changes. The other thing is that we know that in those studies, for standardization, invariably what one tries to do is feed a standard number of mosquitoes on that blood sample or on that person. And we know that individuals are not sampled by mosquitoes standardly in nature. We also know that mosquitoes have differential ability to transmit. They have differential susceptibility to infection. And just to illustrate some of those factors, my schematic here is the three arbitrary age groups we've chosen, which aren't so arbitrary. We're assuming effectively a non-immune population here, clinically immune here, and parasitologically and clinically immune here. This line here is the rainfall in that particularly highly seasonal setting. And what we're measuring with the blue bar is our cross-sectional time point survey. But we know in those children that they will have other infections here during the course of the year. And that at least my experience from work in the Gambia is those infections were certainly of a lower parasite density, the subsequent infections. The adults may well be chronically infected throughout that period. So I think that there is a necessity for some longitudinal assessment of this infectiousness. We know that in some of the work that we've been involved in Burkina Faso, that transmission, these are paired feeding experiments done at the start of the rainy season and the peak of the rainy season. Transmission varies in a slightly unpredictable manner. So the children here were highly infectious at the start of the rainy season, but that dropped in the peak, whereas those clinically immune but not parasitologically immune children seem to potentially even increase in infectivity, as did the older individuals there. So it's not a static state. You're not just infectious a set amount. And again, that will be due to human factors, potentially development of specific sexual stage immunity or asexual stage immunity, which regulates transmission, or parasite factors, and/or, I should say, the conversion to sexual stage forms. Parasites may make more of the parasite component sexual as the infection proceeds, and there's an element of treatment and intervention uptake there. The other thing is, of course, the mosquito sampling. It's influenced by a number of factors. Body size. This is work on Aedes from Tom Scott's group, where on the bottom axis you have body surface area of individual and time indoors. And what the red spots show are matched blood meals from Aedes to their owner of that blood, original owner of the blood, showing that there's a significantly larger number of blood meals detected from adults who spend more time indoors. So there's a fairly basic message there, which is get out more. But I think that's for the dengue situation. But the question is whether that happens for humans, for malaria, and one can think of reasons why that might be. On the right is some data from Uganda from Rachel Pullen, which is basically showing parasite rates in the closed dark blocks and intervention use, bed net coverage by age. And essentially what we're seeing is that the school-age children are not particularly well covered by the bed nets compared to the other age groups. We have a blip around pregnant women age, because they're specifically targeted, the under 5s and pregnant women, and again that coverage drops in the older age groups. So again, what that means is those individuals are there to be sampled more by mosquitoes. And again, one would expect the combination of body size, intervention use and behaviour, we're expecting adults to be out more at night, again to potentially balance that high parasite density in children with increased exposure to vectors in the adults. And finally, what this is showing is differential susceptibility of different mosquito species to infection. In a set of paired feeding experiments with Gambi funestus and arabiensis, and then some work presented in Science a couple of years ago looking at, even within a sibling species, differential susceptibility and transmissibility within that Anopheles species, Gambi species there. So I'd like to leave it there, and just to say that what we're hoping to promote within our linked programs is an integrated approach to transmission assessment, trying to look at all those different facets as simultaneously as logistics allow. We want to understand the similarities and difference between the different human malarias. Ivo's particularly going to touch on the Vivax falciparum co-endemic settings. And even within those settings, there are different ecological systems that are apparent. Within that, we're trying to, using the new tools developed by Harvard and the Swiss Tropical Institute, by molecular characterizing parasites, and then to generate data that we hope will feed into the modelling and control efforts of the general kind of malaria control community. So with that, I'd like to thank you and to hand it over to Ivo. Oh, sorry.